Okay, 5 minutes into this, we are going to start. Jen, ready for this?
Yeah, so for everybody on the call who doesn't know us, the way it usually goes is Scientani's the serious one, and she'll try and actually read the slides they gave us and tell you the content. And I'll come in with my comments, right, about that's not realistic. And we all know what we deal with as data people, right, on a daily basis. So what this presentation is really supposed to do is get you to think, right? So the industry's telling you things, marketing's telling you things, we're getting hit from all sides. AI, agents, Tableau, CRMA is going away. No, it's not. It's here. What do we do? And we still have to do our regular jobs, right? And so this is the presentation they gave us. We've kind of cleaned it up a little bit and added some things that we think might be more useful. But I'd love it if anybody on the call would go into the chat when they see something on here and they say, well, I like to do this instead, or how's that going to work with this? So we want your feedback. We're only kind of trimming this down so we can get through this content that we were given. So normally we would just have a big discussion about it. We're going to go through this. We want your comments, and then we're going to do a follow-up after this. So we're going to talk about how Sayantani and I really do AI data prep. So Sayantani, take it away.
So before that, Jen and I both have been analytics champions since 2019, and then it became Tableau ambassadors. After Salesforce took over Tableau, and we have been running the meetup not through Tableau but using meetup.com since 2019. And
oh wow, 6 years.
Yes, 6 years. Basically, I think July was 6 years. That's when it started. So yes, this you can call it even our 6 year.
It just became official.
Yep, 6 year birthday as well. So yes, from talking only about Wave and Einstein Analytics and Tableau CRM and then CRM Analytics to talking about AI and Agentforce and Tableau Next, we have had a whole lot of journey. Thanks to you guys, thanks to Salesforce for letting us continue to do this. Yes, a big hug to the whole community for letting us do this. Okay, so presentation. Let's get this started with. Of course, we all know why we are here. We want to know how we for AI, for Agentforce, and Next. As you can see, Trailblazing Analytics US and India and Dubai, which also exists, and of course UK. Everyone is doing the same thing. We are all things analytics, data, and AI. We don't no longer differentiate between we want to do only Tableau or we want to do only CRM analytics or we don't want to talk about anything else. So open to you guys. Ping Jen or me on LinkedIn or wherever you find us and tell us what you want us to present on next. Usually it happens every 2 months. So if you have any ideas, you want to see something, let us know and we will try doing our best. If there's a topic we don't know about, we will find someone who knows the topic and can talk about it.
And then we also do our QA nights
Yes.
nights and days now, where we do not record the session, and you can come in and ask us anything you want, as long as it has to do with data.
Yeah, that's basically under NDA. We do not want, even if you are showing production data, it is not going to go anywhere because we will never record those sessions.
And that's even interpersonal, right? It's sometimes hard to be data Switzerland at work. So you can even come in and talk about situations and we'll give you advice because a lot of us have been there, right? We got to protect each other in these situations because data is the new hot commodity. It's basically the new currency in all of our careers, right? And with all the limits and new products coming out, it brings a lot of interpersonal situations that we've never dealt with in the industry before. So we're a safe place to come and talk about that with.
So coming to this, we will cover data literacy. Of course, without that, you can't do any of these things. What is the AI growth chart look like? What's there to learn? What are the guardrails for your AI? Yes, there are lots of guardrails, and we all need to be aware of them. And how do we get all these to Tableau Next and Agentforce ultimately? That's the final goal, and that's why we are talking about it. So, data literacy, it consists of data quality, extremely important. Data quantity, again important. What's AI versus generative AI? What's AI versus machine learning? Then, what is a model? What is a semantic layer? We hear all these terms being thrown all around, but let's dive into them and see where we can get through. Okay, data literacy. So, you need data literacy for building a robust AI system. For through data quality, you don't have a robust data quality, you don't build a proper AI system. So what goes into that? You have data collection, you gather diverse data, you gather representative data sets from multiple sources. When we are talking about AI, it need not be one source of truth or one data set anymore. It can be anything. If you have heard of data cloud, it can take data from multiple sources, uh, assimilate them, and then show you the data, right? So data collection first and foremost, then the quality assessment. You need to evaluate the accuracy, the completeness, the consistency. Are my fields always covered, at least the important fields that need to be there? Are they always filled up? How accurate is my data? Is my data complete? How complete is my data? You cannot have 10% data completeness and say, I am going to show you everything that the AI needs to run. That's not how things are going to work anymore. You need to have completeness. You need to have the consistency in there. Data processing, we clean, we normalize, we augment the data, we do a lot of things. Then, of course, we do the model training, which is we train the AI models for being bias free, for high quality. Without these, AI is not going to be as good as we think it should be. Uh,
I'll have to put a joke in because I know everybody who's watching those slides is saying, but my companies tell me to build the model before I've done the other three before.
Correct. That's all our life. But no, you cannot do this.
Are
And
you
that's,
doing AI? I like when people ask me that. Are you doing AI?
yep, we get that question almost every day. Uh,
This is
so,
super important for everyone on here. The way they have these slides, they're kind of giving you a hidden decoder here that, like, you have to have the data and you have to have the data clean, and then you can proceed to making some things with it, right? All of the normal process we do every day in the data world.
yep, you do this before you go into AI. So that's why we are starting at the base. We're slowly going to build up to AI. So you need diversity, you need representative demographics context, you need accuracy, which we already spoke about, the consistency part of it. Uh, we are again talking about consistency, but this consistency is not just you should have the data in place. This is also the formats and the quality standards need to be achieved. For completeness, it is the coverage, as we were talking about. Are you missing a critical data? How much data are you missing? Bias mitigation. We all know gender is can have biases, age can create biases, race can create biases, ethnicity can create biases, right? So we need to take care of biases as well. And every system or every industry has its own biases. These are the common ones that you come across in Salesforce or in real life, but every industry has its own biases involved. Privacy, extremely important. Data privacy is anonymizing the data, taking the consent for people whose data you are using. Extremely important to do this. And the final impact of this is, of course, garbage in, garbage out, which we keep talking about. Quality data is the foundation of trustworthy AI. High quality data sets lead to more accurate, fair, and reliable AI systems that better serve all users. So, yes, we need to be mindful. So if your clients or your higher ups ask you to do AI, you can point them to the impact that until and unless our data quality is really good, you won't have a trustworthy AI. Jen, you want to do the data quantity?
Sorry, I'm still laughing at the fact that they tell us to do AI and they're like, they don't define the tools. They just they assume all the data is okay. I mean, this is reality. This is everybody on this call, right? When if you're, even if you want to do it, like, sure, I'll build some AI, but you have to have everything so before you can't just do it. So, I always propose those two questions before I read the slide. I tell everybody, when I get asked, are you going to do AI, or where's your AI? Are you working on AI? Because that does happen at work, believe it or not. I say, what tool am I supposed to use and what data am I supposed to use? Give me those two things and I can work a miracle for you. But, a lot of people don't think you need a lot of data storage. The data has to sit somewhere and you need storage, and then you need a tool. And then you're going to need more storage once you start working with it, right? So when you think of like data literacy, I'm realizing that's a very, it's like a lost art, a folk tale, right? All of us on this call who work with data all the time, we're still learning, right? Let alone people who don't work with data. So when you understand, like I'm just going to read this and say, data quantity, this is small scale and production scale and enterprise scale. Those are buzzwords. Really what you're looking at is, you're going to need a data lake that can hold models. So your requirements for success are, you might have the data now, but where are you going to store your results? Where are you going to store your models? What are you going to do with that data once you store it? Can it be retrieved? Et cetera, et cetera, et cetera. So what I would do is I would even like wipe this slide out and say, if we only want to do one thing, like we want to take a, one value and then make it go, I don't know, populate a slide deck, right? Like we're going to take total opportunities for the quarter and we're going to put it in, Google Slides for you. That doesn't need a whole lot of data to do it, right? That doesn't need a model to do it. You're going to overkill if you do that. But then if you want it to learn what a sales rep needs every quarter to put on those slides based on how your industry is moving, yeah, you might need complete data storage. So this might look a little, I'm seeing on here the Tableau people have sprinkled in a little bit from our data manager, a little bit from the data prepper, a little bit from Tableau. So these slides going into AI, I want everybody on this call to remember, are just what we're already familiar with. They're just giving it a very fancy name. So the AI takes all the parts and pieces. For anybody here who's worked on data flows from the olden days, right? In the data manager, and we made our data flows and we made our data sets and we learned compute relative and, all of our favorite little nodes in there. Really, AI is like that. You're just taking the data and you're piecing it out with different sections that take time, take volumes of data. You've got to clean it all along the way and you got to make it do something. And then you got to make sure it runs afterwards. And then when it does run, did it do what it was supposed to do? You know me, I don't like to read slides, but I'll go ahead and read the slide for everybody on here. So let's see, what did they send us? Understanding scale requirements for AI success. Does everybody understand the word scale? First of all, we're not talking like scales, like weighing things. We're talking about being able to grow. So if I build one thing, am I going to be able to build another thing on top of that? Am I going to be able to use this for 5 years later? So I think it's super important that when you're being slammed with all these buzzwords and terminology that you remember it's really very simple. They're just using fancy words on the other end. So data augmentation is, it's saying artificially expand data sets. Data augmentation is just adding to your data. Really, let's just add some flavor to it. Whether you're adding more fields, adding a calculated field, adding more data to your data, that's all augmentation is. Synthetic data is, I like how they put the mask on there, like Kabuki Theater. So basically that's, I'm going to go real easy on this one. Data not generated by humans, right? The machine made a data set for you. And we're just going to leave that there because that's a debatable area. Transfer learning just means that you're going to take your models and then you're going to learn from them. And you're going to use what happened from your models to do a different model. And when they say models, I want you guys to think about a layer you would put between your data. So I have all the data about my company's sales, and then I have the, what I want to do with that. And in the middle somewhere, there has to be data that says, well, our sales were low on that day because that's a company holiday, or there was a product shortage. A lot of times you have something called an abstraction layer that you have to put in there and say, the data really means this, and only I know that because I'm a human and I'm in the experience. I'm not the machine. So transfer learning is when you take what you know as the person about the data, enhance your data with it, and give it over to the machine, and then the machine comes up. With it kind of spits out like its own interpretation of it. Whether it's right or not, that's another story. Active learning, we're actively learning all the time. And then data sampling. Oh, somebody has an emergency. Stay safe. I know it's flooding over in India right now in certain places. So I hope you're okay. Sorry, I saw that in the chat there.
No, that's good.
Data.
Recorded. So
People are more important than what we're talking about here.
yeah.
We need everybody to be okay, or this doesn't matter, because then I'm just talking into the void. You want to help me out on data sampling, Saitani?
Well, ideally, when you are doing any kind of model, you start with a sample of the data, but that data, subset of the data has to be representative. You cannot randomly say, I'll take the best data available, and then I'm going to run a model on it, and then use that model on the larger data set. You have to have a representative subset of the larger data set on which you run the model as a test, and then you run it on the full data set.
Making sure that data is accurate, right? And accurate representation, because it's not any good if you left a column out of there that has a number that actually would
Impact. Yeah.
With it. Okay, that makes sense. Yeah, some of their wording, I wouldn't call that data sampling. That's more of like data protection for me. Like, do we have all the fields we need, right, to do this? And then the few shot learning, that's another one that kind of like bothers me a little bit when people say that, because like, who are you shooting when people say that? Nobody's getting shot. And it's funny because Saitani is actually an engineer. She went to school and has all these fancy degrees. I'm 100% self-taught in my career. So you're getting the contrast between somebody who's very familiar with all these terms on here, and then me who's like, just tell it to me in plain English, right? And so what I'm trying to tell everybody is it's okay to be between those styles, right? Like, you can have the highest education on all this AI terminology, or you can be like me, who just, worked my way up from scratch, right, to this position. And I hear these words, but I've never sat down and studied all of them. But at the end of the day, I can do data just as well as anybody else can. Do data, do AI, And so everybody on this call is like that too. Would you say few shot learning actually means, what would be your decoder for that one?
So the way I think about few shot learning is you train multiple models on the same data set, and then you use it to find what is the best one, and use that final learning to apply to the bigger data set that you have to do your AI or transformations on.
So what would define which one's the best?
That depends on the accuracy of the model. That's why data sampling becomes important. You cannot take everything I'll take only the rows that have 100% data. That's not how real world works. Or I'm not going to take any of the messy data that exists. I'm going to take a very clean data set and run my models on that. That's not representative of real world. So that's why data sampling plus running multiple models gives you the best idea of which AI or machine learning or generative AI tools to use for this.
Yeah. So the last key insight on here, and I would take a screenshot. Anybody here who's having to deal with this at work and talk about this is a nice little handy thing. If these words are being said to you at work, and you're just trying to do your job during the day, you have a little kind of a cheat sheet. But the more data, the key insight from this is more data isn't always better. We already all know this, right? You could have all the data in the world and it's dirty and it doesn't mean anything. And you could have 10 rows and that like tells you everything you need. Um, so the point is that AI is really just trying to, if you're able to go through all these steps, get it to where, it's in a format that is usable. If I break this down into very layman terms for everybody on here, all we are doing is taking data, segmenting it out again, adding to it, just like we do in our regular jobs every single day. And then we're using tools that are putting it together in different ways for different use cases. And while they're doing that, they're correlating, right? They're saying, oh, I see this word over here and over there, or this number, or this pattern, the same patterns coming up. Like every 7 days, I see the same number again. And it takes what it learns and creates new data from it. So it's the equivalent of you or I sitting down for weeks and weeks and watching our data and then figuring it out because we see the pattern. It can do it a lot faster. So that's the part of AI that I'm really all for, is the part that saves me from having to sit down and watch something until I figure it out myself. The tools can actually figure that out for you. So look at it more as a complement to what you're already doing rather than something that would take your job in the future.
Perfect. Yes, absolutely. Okay. Well, traditional AI versus generative AI. We talk about agent force. That's generative AI. If you have ever done Einstein discovery, that's sort of traditional AI. Einstein discovery, for those who are new to this, is part of CRM analytics. And it is basically machine learning. So when we talk about traditional AI, it analyzes, it predicts, and classifies your data. So linear regressions and all those kind of things are part of traditional AI. Random forest is a traditional AI because that's a machine learning thing. So pattern recognition, analysis, classification, prediction, rule-based decision making. So if you are in Salesforce, you know what workflows and flows and process builders used to do. Flows still do, but workflows and process builders no longer being there. But those are rule-based decision making. So technically, that's called, that what used to be what AI was, also an automation tool. So you optimize and automate, and then of course you get fast deterministic outputs. One good example from Salesforce point of view for traditional AI is case management. If you're doing case management using the case management tools that Salesforce has, you're doing the traditional way of routing things. So that routing that you do is the rule-based decision making. Generative AI. Well, we all know about Claude. We all know about Gemini. We all know about ChatGPT. That's the generative AI. Agent Force is generative AI. What does it do? It gives you new contents, images, texts, and media. So content creation and synthesis, creative and artistic outputs, natural language understanding, probabilistic generation, and novel creative combinations. So I'm going to give you a very good example of this. So when this slide came in initially from Salesforce, it was a lot of writing. And those of you who have seen our previous presentations, Jen and I, we don't like reading out from slides that have too much writing in them. We like posters, we like information in there. We don't like to read out texts. We hate it.
Cheat sheets.
Yeah, we don't like that. So what I did was, whatever Salesforce gave us, I took it to Claude and said, make this into an informational page. So that created this for me. So I took the data out of what Salesforce gave, which was all text. sent it to Claude and said, now I need this in a better format that has images and things and not texts, because I am not reading a text thing out to every month. Okay, so data literacy, AI versus generative AI. Of course, we are still talking about it. How do we understand the difference between them? We already went through. The primary purpose of traditional is analyze and predict, generative is create and generate. The output type for traditional is classifications and scores and decisions. And for generative AI is text, images, audio, code. We do a lot of coding. You can actually build websites using Claude and Gemini today. Data requirements. For traditional AI, you need structured, labeled data sets. That's why case management works so well with the traditional method. But generative AI needs massive, diverse content, and unstructured data falls in that. So if you write a huge blurb of text, generative AI can read it and tell you how sensitive that is, or should you be sensitive to what has been written. Training focus. That's for training. For traditional AI, you need task specific accuracy. Again, when you're automating case management, it's a task specific thing. But when you're going to generative AI, it's pattern learning. It's seeing the texts you're sending it and learning from it every day or every time you ask a question.
I wonder on here if people, I wonder how many people on this call were like, oh, that explains a lot. Um, they don't just come out, they make everything sound very, very fancy with AI when at the end of the day, it's just data. It's just patterns. It's really what we do as people who are visually oriented. That's our normal jobs every day. We combine that with critical thinking skills, right? And then we work with data. So they're just doing all of this with computers, right?
Correct. So the top part of this fold, where it says email filtering, autonomous vehicles, and fraud detection, that's your traditional AI. So fraud detection has been happening with credit cards for the last 15, 20 years right now. So that's actually AI. There are tools they are using, there's machine learning behind it, which is analyzing the pattern and telling you, okay, this looks like a suspicious transaction because we know you have never been to that part of Europe. So those are fraud detections. Email filtering, since ever, whenever we started getting spams, there's email filtering happening. Autonomous vehicles, they use for navigating the road, they use sensor data, they use cameras, they use a lot of things to make the autonomous vehicles run as is. If you are in US or guess most of the world right now, you know Tesla is an autonomous vehicle. Of course, supervised driving, but it is still autonomous.
Yeah.
Whereas there's in San Francisco, and I think now in Phoenix, you have Waymo. And if you ever go to Dreamforce or San Francisco, you'll see these autonomous cars with a giant wheel or radar on top of it that runs. There's not a single person driving it. It's automated driving, and the passenger sits at the back of the car. Uh, it's very cool to be in or ride. And anyone who is remotely interested in vehicles, I think you should do it once. You will be amazed. Okay, with Waymo, I'm not talking about Tesla. I'm talking about Waymo. Uh,
If you're claustrophobic, it may be a problem.
no, I think you can open windows, but I don't know. But yes, it's awesome. Uh, Opposed to that, you have ChatGPT, DAL-E, which is the original images from text descriptions it can create. And of course, those of you who are using GitHub Copilot, you already know about it. So uh,
You
that is
let
the
the
generative AI.
secret out, Science Honey. Look, AI is not new.
It's not newly.
I've been working with it. Yeah,
So
that's so funny because everybody's like this new thing, right?
correct. It's not new. So traditional AI, it excels at analyzing and making decisions from existing data, like we just talked about. Generative AI, that represents the paradigm shift towards creativity and content creation. So we are creating something from something that doesn't exist. And they both work together. You cannot have one without the other. Let's say you're talking about data. Without the data, you cannot have traditional AI or generative AI. You need data. Your basic need is good data quality. You don't have that, none of this is going to work. Okay, I guess machine learning. I'm hoping some of you know what machine learning is, but I'm still going to talk about it. AI is a broader concept of machines. So, what AI is this huge giant ball you can think of. Part of it is machine learning. It's a subset of AI. So, whenever we are talking about random forests and decision trees and neural networks and everything, it is still AI, but it is called machine learning. When we studied, we learned it as machine learning. No one used to call it AI, though we knew that, yes, it's using artificial intelligence. And when we studied, we used to call neural network as black box because you don't know what's happening behind it. It's working. It gives you great insight into your data, but you don't know what it actually is doing. So we used to call it the black box. Yeah, there's some way of learning, right? So we used to have terms for everything. Neural network for us, I still remember, is called a black box. Okay, so what's the difference between artificial intelligence and machine learning, as we learned? And if you have ever done set theory, you know this is called a subset. This icon is a subset if you have done set
I
theory.
was going to ask why that U was on its side.
It's called a subset. Set theory taught us that's a subset. Like if you do union, it's a complete U, right? So that is a union. Intersection also has its own version. Intersection is if you reverse U 180 degrees, that's called an intersection. So this is a subset.
Okay, I just learned something. Maybe I've seen that, but I'm like, that's odd. I didn't know that's what
Yeah,
that
being brought up in India, set theory, they hammer into you since I think grade 8 or something, right, guys?
10.
Okay, 10 for you. For us, I think it was since class 8. It has been hammered into you about
Yeah, yeah.
theory.
Like we start with statistics and stuff from pretty small age.
Correct.
They don't let you have statistics out here unless you get all your basics, like when you're in college.
No,
You don't get
our statistics
in
starts.
school, in like elementary school. Oh,
Yeah.
interesting. I'll just tell my kid. I'm gonna tell my 14-year-old he needs to go take statistics now.
Okay, so artificial intelligence, which we have been talking about for quite some time now, broader field encompassing all smart systems, autonomous cars, emails, everything. Simulates human intelligence, of course, because if you're looking at spams, instead of you filtering the spams out, something else is filtering your spams out. Instead of you doing case statements and routing them on your own, a system is routing them. So it's still a machine doing it. Rule based system, it's problem solving and reasoning. And it is, of course, goal oriented because if you're taking case management again, it's goal oriented. It needs to go from uh, the support task, it needs to go to a certain person. So that's a goal oriented behavior. Well, machine learning, which is a subset of all this, talks about what you learn from the patterns from data. That's what I was saying. Neural network, decision trees, they tell you what you learn from the data. Improves through experience. The more data you provided, the good data. I'm not talking about the worst data. The more good data it has, it improves the experience. It improves the final accuracy of the model. Statistics and algorithmic approach. When we talk about machine learning, it's all statistics, lots of statistics. If you have heard about R squared, that's statistics. If you have heard about average, that's statistics. Mean, mode, whatever we used to do, this is all statistics. Prediction and classification, we do that always. Automated model optimization, we are going to talk about it in a bit. So we learned about that. Now, what are the differences between artificial intelligence and machine learning? Artificial intelligence is a broad field. Machine learning becomes a subset of that, which is data driven by learning. Uh, what is the approach for artificial intelligence? It's logic, it's rules, it's learning, it's reasoning. Machine learning is statistical algorithms and data patterns. So it finds the data pattern and tells you how it will go in the future. It predicts the future. It tells you these are the things you need to look into. You have 10% outliers both ways, and maybe you want to remove those outliers before you run the model. Those are machine learning things. When you talk about implementation, rules, knowledge bases, machine learning, neural networks, which I kept talking about, are all artificial intelligence. When you talk about machine learning, algorithms that improve with data, that's machine learning. Goals, simulate human intelligence, that's a goal. Machine learning is learn from data to make predictions. That's the best use case of machine learning. Now, what's the difference between them? So, this part, the expert systems, natural language processing, and computer vision are your generative AI. Linear regression, random forest, neural networks are your machine learning. The difference being when you are talking about expert systems, it's rule based, it's predefined, and it makes decisions. Natural language processing, that's a generative thing because it's understanding what you're talking and talking about it. Uh, Computer vision. Computer vision also is, it's looking, how do I explain computer vision? So if you have done Python, it will be easier. There's an library in Python for computer vision. If you have ever tried it out or not, just look into it. You will be amazed on what Python can do with computer visions. Also, I, if you have, it's called Einstein vision in Salesforce, that is also computer vision. Just an FYI. Uh, Linear regression, random forest, we already spoke about, so I'm not going to go into the depth. Key insights, all machine learning is AI, but not all AI is machine learning because you also have generative AI. So that might not be machine learning. Uh, Also, machine learning is specifically focuses on learning patterns from data to improve your performance.
That was a lot, Science Line.
Yes, it is a lot. I know.
I'm on the other side. She went to school for this, and I'm on the. Okay, what does that mean to me? Like, that's all great, but what does all of this mean? And basically, that was just a sample platter of all the different kinds of AI that are out there and the terminology that they're using. And really, it's not the AI that's out there, it's kind of different ways we can work with data to create
Correct.
AI.
Correct. So the way I would put it, Jen, is if you hear the word machine learning, generative AI, don't be afraid of using them. Everything you're doing mostly is already AI. Plus, if you're thinking about machine learning, there are great guides out there. One of my favorite guides for learning about machine or for understanding how machine learning things work, it's called Analytics Vidya, and I can post it somewhere. It's an Indian site, but it gives you great insight in explain like I was five, I'm five kind of way. So it's
Okay, so I want to ask you a question.
hmm,
So then, okay, so this is going to date me for everybody on the call. So in the like late 90s, when I was building a scholarship database for the state of Arkansas, and it had my little front page on the web with the ODBC connector, and it matched students up and it to the, scholarships that were best suited for them. Is that AI? If you have a giant server full of all this information and
yeah,
you're taking, okay.
yeah, yeah.
And then I did another job where I worked at a machine tooling company,
Mm-hmm,
and they had software developers there.
mm-hmm,
And they had these machines that they would put like in factories to do
mm,
different things. And after you use them for a while, the machines would learn how to do the job better. And
yep,
this was in
machine learning. Yeah,
the late 90s.
yeah. And
Okay.
I know this because my dad is a chemical engineer. Uh, so I have been to, so my life was I would do anything my dad does. The reason I'm an engineer. The result of that is I used to spend some time during holidays or weekends. If my dad is going to the factory, I would go with him. And I would actually go not just on the actual machines to see how things are working. I would even go to the control rooms and see how they are working. And of course, there would be a human sitting in the control room, just to see if something is going wrong. But there would be this giant screen in there which will show you, okay, the raw material is flowing from point A to point B. The heating temperature is currently this. If it is going up, then you reduce the heating temperature on its own, and then it continues the flow. Finally, the total amount of material that came out, it gives you how much the material comes out, and you have this whole process in a very nice diagrammatic form, and it actually shows you every point how what is happening. That is all this we are talking about. That was also in 90s.
So the interesting thing is a lot of people are scared right now, like, I'm going to lose my job. The AI is going to come do my job for me. And is it really that we're not looking at this in the way that the AI has already been there and the AI can help do part of your job? And mind you, I'm not trying to be a marketing person for any of our products that we're talking about here. But it's more of an integration of things that used to be available exclusively to people with a lot of money and companies is being broadened out to where we sit, right? So all of a sudden, a tool that would help us do analysis wasn't available to our companies or even to us within our companies years ago. It's now somewhat going to be out of the box.
Yep.
It's interesting, isn't it? It's interesting that something that used to be exclusive and a lot of money for companies, a lot of, development time and people is now like pretty much canned in you know, a digital twin on the internet that'll write a thesis paper for you.
Mhm.
All right. What's this universal definition? Tell us in your college terms.
So you are training model, right? uh, the model, it needs inputs and to produce the outputs. So think about a raw material, forget data. Think about a raw material. Think about concrete, for as an example, civil engineer, so concrete comes to my head at all point of time. You need cement to start with. Without cement and water and some gravels, you cannot have concrete. That's your raw material. You cannot say, I will build concrete out of nothing. You need the minimum basic thing. In our case, we need the minimum basic data to produce an output. Now, this is also based on what we are talking when we talk about model. We are saying it needs to learn the patterns. Machine learning was learning the patterns. Generative AI is learning the pattern of the data. That's how you create a model. So the end result of this training on data is it's a mathematical function, not just statistics, it's everything included. It predicts, it classifies, and then it generates new content. As an example, as I said, Salesforce gave us this whole write-up. All I did was I took the write-up, I sent it to Claude and said, can you please make this into informational diagrams and not give me so much text. That's what I did.
Oh, I wish you would tell that to people I work with, have them tell it less text. I get like a thesis paper for everything. It's like I needed one thing and I got 12 pages.
Same. Okay, for those of you who I just spoke about analytics with Dia, so I'm going to post the blog link here and you
Oh,
can.
what's this comment in here? The better quality of the cement, gravel, sand, and water, the better
Oh,
structure is the
Shrodip
final.
already posted.
All
Also,
right.
Yeah.
the
Yeah.
better quality of cement. Correct. Exactly. Thanks, Shrodip.
So I
And
hope everybody on this call knows that we're in our rest period because all of us data people, while everyone's trying to figure out if they're going to get AI, do AI, implement AI and agents and models and all of that, guess who's going to have to come in and fix all of that when they get it set up? All of us data people. When they
Yep.
say, I don't understand why this isn't working. Oh, your data wasn't clean, right? You don't have an abstraction layer. The automation isn't running on time. You're hitting limits. There's a lot of parts and pieces in our future.
Yep. Okay, so talking about models, AI models, generative AI models, and ML models, right? ML is machine learning, just in case. Uh, So AI models are intelligent decision making systems, whereas generative AI is creative content generation, and ML models are data driven pattern recognitions. We were just talking about it. What's the purpose of all the three? So AI models is simulating human like intelligence and reasoning to solve complex problems. Generative AI is learn data distribution to create new original content. And machine learning is historical data to make accurate predictions on new or unseen data. Now, some examples. For AI models, of course, medical diagnosis. It has been happening for years now. Uh, Game playing, AI. You play chess or you play other things. Even, I guess, some of the card games you can play with a machine, right? The other side is a machine when you're playing games sometimes. Uh, that's an AI model. Natural language understanding, again, AI. Computer vision, we just spoke about. That's an AI. Generative AI models is, we are giving examples, ChatGPT, Cloud, Gemini, all of them. Dolly is an image creation, music generation models. Yes, there are music generation models right now out there. If you want to create music, you can ask them to create music for you. You can also ask ChatGPT to create a poem for you. And I have seen people do it. Code generation, of course, those of us who are using Copilot are well aware of Copilot. And again, linear regression, decision trees, neural networks, support vector machines, which otherwise is called SVM, are all ML models that are well known. So just in case, linear regression, as I was explaining, is basically kind of price prediction, or in some cases, if you're using opportunities and things, one loss, that is your linear regression. Decision trees are classification models. Is a classification model. Neural network is, of course, deep learning. SVM also falls under both, actually, deep learning as well as decision trees. Sorry, classifications. Uh, Again, characteristics of AI models, generative and ML models. So, primary function of AI models is intelligence decision making, generative is content creation, and ML is pattern recognition. For the input for AI model is, it varies, of course, problems to solutions, what you need, you have to give the input accordingly. Generative AI, also, you need to give the prompt. The better prompt you create, the better content you get. Same thing with MLs. The better features you have, the better predictions you will get. Training focus. AI model is problem solving. Autonomous cars, it's solving a problem someone is not driving. uh, Content distribution patterns, generative AI, statistical relationships, ML, of course, decision trees, neural networks, everything is a statistical relationship. Well, complexity, high multifaceted intelligence for AI models. Complexity for generative AI is extremely high, whereas if you come to ML, it's variable. A decision tree is not as hardcore, or a linear regression is not as hardcore as a, let's say, neural network. So that's why it depends on what task you're asking it to do. Oops, sorry. So we were talking about concrete. So think of input as the raw materials, cement, gravels, sand, water. All of this goes here. Then you process it. Uh, I have not seen this in US, but in India you have these giant um, concrete vans that run in trucks that run this through. You just put everything in, it runs through, and then it creates concrete on site. So that's the processing. Once done, it's a computation, and then you have the final output, which is the, so this computation, you can think of the cement, the concrete is almost ready to come out after all this processing has been done. Also, you have to maintain a temperature in there, because without that, your concrete might harden very fast, or not harden in time. So a lot of things goes on in there, in that truck that we have seen. And then you have an output model, which is, of course, in our case, concrete. So key insights for this: whatever domain you take does not matter. Your model is the trained result, right? Ultimately, this is your final training set. result. So it's a mathematical representation that captures learned knowledge. We learned all of this, and it is deployed to solve real world problems. And the organizations we work for are also real world: medical field, energy field, real estate. Uh, Jen is into internet product things. So all of this. Shubhadev is into hotel management. So all of these, they are all real world problems. And then you take all of this, and this is your final training process. That is what your model is doing.
It's interesting, isn't it? Because it's all just data at the end of the
It's
day.
all data.
It's
Yes.
all data. Like it's not scary. There's no like, you know, entity on the other side that's, maliciously thinking, you hear all these stories, right? Like the AI went wild and the AI, broke all of our stuff or didn't do what it was supposed to. That's because somebody put bad data into it, not because it's actually, a living, breathing thing that has a malicious intent, right? So it's kind of funny how we forget that unless your data inputs are exactly the way they should be, you're not going to get the result that you want.
Hmm.
And if
So,
letting it learn, you have to maybe let it learn thousands of times to get it
yep,
right.
yep,
It's like a
absolutely.
child.
Okay, semantic layer. That's where Tableau Next comes in. That's the translation bridge between data and business understanding. For those of you who have not seen semantic layer till now, there is a trailhead out there. Shubhadeep, if you can post the trailhead, that will be great. There's a semantic layer trailhead out there which you can use. Also, if you want to learn about Tableau Next, there's also a Tableau Next trailhead out there.
And the
Mhm.
conversation, this is, sorry, like I almost called it conversational analytics from the old days.
It is. It is.
If anybody's from the old wave EA CRMA days, we used to have the little conversational analytics the feature you could turn on in there. And,
Correct.
and people kind of just didn't make a big deal out of it, but that was AI, and
That is AI. Exactly.
it learned from your org. That little thing
Correct.
knew a lot more than we knew.
Yep.
But now we've taken that and put it on steroids and put it
Yep.
in the Tableau Next product. So
Hmm.
it's funny, whenever I see semantic layer, I always think conversational analytics in my
Yep.
head.
Yep. So a semantic layer is an abstraction layer. It sits between the raw data source, we were talking about it, and the business application. So our raw data source in this case is cement, sand, gravel, and water. And our final business application is putting the concrete on the building. So that's the that is the abstraction layer which is sitting in between. You can think about the truck, the concrete truck that I was talking about, as the abstraction layer in this case, translating complex technical data structures into business friendly terms. So we hopefully, Jen and I, have tried to make this more business friendly and user friendly than just using technical jargons, but semantic layer is trying to do that, and ultimately providing a unified, consistent view of organizational data. So you take data from, let's say, AWS, Azure, Salesforce, CSV files, Excel files, whatever you have, and then you bring all of them together into one consistent view for the for of organizational data.
So think about it. I like to think about it too, where your prompts are really important. So if anybody ever worked with conversational analytics and somebody said, "Tell me what my sales, what's my sales," and you're not defining any kind of parameters in your prompt, it could give you anything. What are your sales? That's a really good question. Um, but if you say like, I want my sales for end of quarter by opportunity amount, you're going to get a more proper response. Oh yeah, there's the link to the semantic model, but it's really about inputs and outputs at the end of the day. So rather than like me using my fancy words, I always say at work, "Oh, we're building something so salespeople can just go get their data instead of analyzing it themselves." right? Something where they can just ask a question. But this is good. This is probably, essentially, I never thought about it. We've been friends for how long? Since 2017. We make a good pair because I'm very, very layman. I'm very just, what actually is this without any fancy words? And you've studied all these fancy words. So you guys on this call are getting the best of both worlds, and both of us do the exact same job at work. So it's kind of funny. It just goes to show that, if you got the data gene, you've got the data gene, right? If you can work with data, fancy words or not, we understand in our minds how it works. Is this their actual data architecture stack for their product?
No. They are talking. Everyone is still talking about it. I'll come to the actual architectural stack.
I see architecture and I'm all invested now.
Yeah. Theirs is very complicated, so this is a much simplified version of that. I am going into the complication on a later stage. So let's start with the simpler version and then make it complicated.
Got it.
Okay, so data sources. We kept talking about data sources, databases, data warehouse, APIs, files, various data repositories. Way too many of them. Then you have your semantic layer where you put the business logic, the metrics definitions, the data relationships. Calculated fields are also semantic layer. Also, if you have ever done calculated fields, you are transforming the data. So just remember that. Even if you're doing just an addition, you're still transforming the data. So if someone has asked you if you have ever transformed the data, 100% answer yes. Because even doing an addition is a transformation of the data. Business intelligence tools, Tableau, Power BI, Looker, visual platforms, CRM analytics, everything comes under the business intelligence tools. Why CRM analytics is not there is, well, people mostly talk about Tableau and Power BI when they're talking about architectural stack. No one talks about CRM analytics. Business users and applications, dashboards, reports, analytical tools. They're all the business users, use cases, and the applications behind it. So the bigger explanation of this is going to come up. Now, without the semantic layer, you cannot do your complex SQL queries, which for us, even if you're doing CRM analytics or Tableau, for data prep, if you don't do your SQL queries right, you will not be able to do anything with it. The technical knowledge base, you need a technical database knowledge to do this. You need consistent metrics across teams. It's slow and repetitive data preparation. Think about this in the form of Excel. If you have been given an Excel and you have been asked to modify the Excel every time even a new row of data comes, you need to do that whole process again. So that's where semantic layer wins, because you can put in thousands and millions of rows. Because you created everything once, it stays, and you don't have to update it on your own every time. That's where the whole win happens. So it's a simplified, unified data access. It's business friendly for data exploration. It's self-service analytics for all users. You can create your own calculated fields. You can add your own data. You can do whatever you want. It will give you consistent metrics across all the platforms. So the other difference being your Excel can be out of date, but if you're looking at the semantic layer, that's not out of date. You might have a cadence of when the data comes in, but that's not out of date. Every person looking at it will get the same view or the same data, as opposed to Excel, which can have 5 different views laying with 5 different people. And yes, that's the reality of this world even today. You get faster insights and reporting. You have built-in security and governance. The difficulty with Excel, as an example, for data security and governance, you don't know who's sending the data, sending your Excel sheet to someone who should not have access to it. You have no security there. But the moment you do semantic layer, there's security built in. So, again, data abstraction, we just spoke about it. Then you have a business context associated with it. You have consistent metrics. We also spoke about it. It's self-service analytics. So anyone can go and add a calculated field and do what they want with it. Data governance, of course, very important, security and everything. And it's performance optimization. So if you have looked at CRM analytics dashboards, I run one of our data sets is 60 million rows. It takes 3 seconds to open up. Try doing that without the whole semantic layer and data set being flat. Try doing that. I have Tableau before it had data prep. I had tried 173 million rows to put a dot on a map. It took me half an hour to 45 minutes. It was that slow. And that was 2015, by the way. So don't tell, I'm not coding Tableau as of today because now there's data prep, but that was a 10-year-old Tableau when things like this did not really exist for faster performance. So back to how it works. We define the logic, then we map the data. So every database that you take or APIs, you need to map the data sources. Let's say customer from Azure should equal the customer, matches the customer or is the same field on AWS, is the same field in Salesforce, right? So that's called mapping your data. And then, of course, we are transforming. As I said, even if you do an addition, it's the transformation of the data, creating a model, and then you serve the analytics. So when it says it's an universal translator between analytical, technical data storage, which is taken care of by data engineers, and the business understanding, not everyone is technical and we don't need to know how a data storage works. It transforms complex database schemas into business concepts, enabling self-service analytics while maintaining data consistency and governance. Someone doesn't have to go to a statistical person to ask them to create a mode or mean or a variance for them. You can do it on your own. Okay, that was a lot. But,
I
and we
know, I worry here, like for everybody on the call, like where everybody's at, like if they're getting the gist that it's a lot of words, but we're still doing the same thing at the end of the day, or if they're overwhelmed by all the terminology in here. It'd be interesting to see where everybody's at on the call.
uh,
Read if you're alive.
Akhil, your question, yes, Jen already answered. It's all data. Exactly. So, yes. I did see someone else had asked a question. Uzma, I'm going to come back to your question when we talk about Agentforce. So hold your breath for that. Okay, so preparing data for AI. It grew very quickly. The AI we are talking about right now is not machine learning and everything Jen and I did in our childhood. This is more about last 5 years, what happened, the generative AI part of it, not what we did in our childhood, starting from there. Where AI struggles, where it excels, and how do you take advantage of this? Let's get started. And I promise you, this is the last before we actually go into what Salesforce shows us. So Salesforce called it toddler to teenager, and I asked Google if there's something called toddler to teenager. Apparently, that is the technical term for AI now for the evolution. It is called toddler to teenager. Do not ask me why. I still didn't get it, but that's what they told. That's what even Google says it is called. Okay, so 2019, just before COVID, it's toddler years. Simple chatbots, we all know about it. Image recognition for basic objects that existed. Translation with frequent errors. Yes, I'm not going to talk about it. That's another story of how translations happened. Couldn't understand context or nuance. I still think there's a problem with that, but that's a different question again. It needed extensive training for each task. That was toddler years. Teenage years is where we are today. It's a little more sophisticated understanding, though I don't think teenagers understand much. But Jen, you can tell me more because you have a teenager. So complex reasoning and problem solving, multimodal
I just
capability.
get the Gen Z stare. This is a new breed of teenagers. So everything we've ever known about teenagers has been like they're rebellious and
Yep.
they buck the system and they do what they want. this breed of teenagers, they're smart. They've always had the internet. They know more than you do about any topic. And I'm the parent that, within reason, has let my child have the internet and look up all the information. He gets straight A's. He comes home and tells me how the infrastructure of the school isn't set up correctly. And, you know, and then if you ask him, like, how was your day? How are you feeling? You just get the stare. So I really, really hope that this AI is not going to go down that path. I really don't like relating this to people at the end of the day, because people will never cease to surprise you, right? I want my AI a little more compliant than that.
Than your teenager. Yes. So complex reasoning and problem solving. Well, if you talk about that, when we were doing math as teenagers, we did do a lot of complex reasoning and problem solving. Multimodal capabilities, text and images, codes, context awareness, conversations, creative content generation. We spoke about it multiple times. Real time learning from interactions. Of course, we spoke about that as well. 2029 is when the AI evolution thinks to be a young adult. That's in another 4 years. Don't know how that's going to work. But autonomous task completion, kind of, we are doing it now. Advanced scientific reasoning, not there yet. Seamless human AI collaboration. Nah. Real world robotic integration, we are seeing with Waymo. Yes, partly it's there. Personalized learning adaptation, that also exists. Okay, where does the struggle? Ultimately, we want to know for our higher ups and for us, where will AI not do a good thing? It cannot make coffee for you, it cannot fix your car, or it cannot perform delicate physical manipulations. Talking about this, I recently heard someone say, I'm not going to use AI till it can do my laundry.
That was me. I
It
said
was you, right? Yes,
that. Well, no, I meant like in a broader sense,
I
right?
know, I get it. But yes, okay, long-term learning, long-term memory and learning. So it starts fresh with each conversation. It doesn't remember what you were talking about before in some cases. So your chat refreshes after certain amount of questions, and you need to go back and tell it to remember the previous ones. It still doesn't. uh, Real-time information, there's a cutoff date. You can't browse the internet independently, of course. uh, Not you, as in AI cannot do it independently. It needs access to live data with specific tools. And true creativity and intuition, of course, excellent at remixing existing concepts, but struggles with true novel ideas or the gut feelings humans rely on. We all have gut feelings, that's not going away. So if someone says AI is taking your job, how will they work
Yeah.
when they need the gut feeling? That's not going to work out. Where does this excel? Speed and accuracy or consistency. Pretty fast. It doesn't get fatigued. It doesn't have mood swings. It doesn't take days off. It works on also on holidays. Pattern recognition, data, text, codes, whatever we might miss, it can catch it. Also, it doesn't take it 7 days to catch a data error, which when we are working on and looking at it at a screen, our eyes get tired, our brains get tired, and we might miss the pattern. So that helps. Interact, iteration and refinement. It never gets tired of revising, editing, typing. Think about it. If we have been asked to revise something 10 times or trying to explain the same thing 10 times, we will get irritated. That's human. Knowledge synthesis, it combines all the multiple domains and then it gives a very good explanation for complex topics and make connections. I would say please take everything that you are learning from AI, especially generative AI, with a grain of salt and do your own checking, because I recently found out that at least Gemini doesn't do good calculations yet. So,
Oh, I'm going through that at work right now because
see,
that's what we have. And when we first, sorry, we're going to have the cultural language. I'm going to sound very Western. Gemini. We are in the process of like, are you going to do AI? And I'm like, oh, so the first thing I thought was, I'm going to take some of my really big data sets, right? Like event logs. I'm going to throw them in Gemini, and I'm going to have it tell me, do all my analysis for me. Give me the top 10, whatever, right? I throw it all in there, and guess what it says? Oh, your organization doesn't allow Gemini to actually query your data. And what I'm trying to say is that we have all of these tools like Chappy GPT. Kids can get their papers written. We have tools that could imitate us analyzing things. But the cost to do that, that's like a cost per query, kind of like Data Cloud. And then the setting it up to actually find the right things and spit out the results correctly without doing a data breach, with keeping the proper security for all your users. We've got a long way to go, right? So everybody here on this call, I want you to understand that use this to your advantage, because you're the data person who can get in the middle of this. So I'm spending my days going around to all my different departments and different people. They just call me when there's a problem with data, and they're like, hey, I'm trying to use the AI to do X, and then I'll say, oh, well, you can't just build an MLM. Like, it doesn't work like that. So everybody on this call, I want you to think about automation is AI, right? That's kind of like the smallest link in it. Start very, very small and think big, and get in the middle of everything your company is building so you can make sure the data is okay.
Yep.
And that's where you'll survive this. They cannot replace you for that part. So they can replace maybe people who write code because they can get a code generator, or a customer service person because they can put every variable a customer might call in with. But they cannot take everything about data that we have in our brains and make that into AI. That's not
Correct.
a thing.
That's our power.
So this is our playground.
Correct.
You're resting right now, everybody on this call, because as we get CRMA, Tableau Next, Salesforce is coming out with everything in its brother, with Agentforce, and I heard something called an admin concierge the other day, and you're going to be the person to say, hey, we can't do that because we're out of storage. We can't do that because we're out of limits. We can't do that because that field wasn't populated.
Correct.
So same problems we have on our daily basis. Just think of AI as kind of like a new department of users.
Correct.
Right?
So we do have 10 minutes. So, and
let's
both have a hard stop. So let's go a little faster now. Okay. So what are the advantages of it?
It's like the never-ending.
Correct.
Yeah.
That's why we said if you want to
I'm going to be quiet.
We'll take it slower next time. Okay. So use AI for research, brainstorming, drafts, code review, data analysis. That's all for our advantage. AI collaboration, context, intuition, real world knowledge, all that we are talking about, Claude, Gemini, Agentforce, all of that are in there. Iterative workflows. We were already talking about case management. That's an iterative workflow. Learning accelerator. You can you can use all of these tools to learn at your own pace while taking advantage of AI. So, pro tip, the magic happens when you combine human judgment with AI capabilities. Think of AI as your incredibly smart, tireless research assistant who never gets coffee breath but still needs you to make the important decisions and provide real world context. The future isn't AI replacing humans, which Jen has been talking about, it's humans with AI superpowers. So, yeah, it's still humans, but based in AI. So, structured and unstructured data. Unstructured data is where everything lies. It's when you're talking to someone, When you are writing an email, those are all unstructured data. The performance behind that is, of course, going to be poor. The human time for that is high, and our level of frustration, I already said, is maximum at all points of time. When you go to structured data, it's structured, right? Like it says sales report, it says salesperson, it has nicely written out everything, every column has been separated out. So in that case, your AI's performance becomes excellent, your human time becomes minimal, your frustration level hopefully goes to zero. Creating it for the first time will be frustrating, but then it'll go to zero. So how do you structure your data? You use consistent labeling, like I was just explaining. Customer name in Azure, customer name in AWS, customer name in Salesforce, customer name in your CSV file. They're all customer names. You cannot call them client, buyer, everything everywhere else. Consistent labeling matters. Separate data points. So John Smith, manager sales. Instead of that, if you split it into name, title, department, it becomes much better. Standard formatting. Use the standard ISO format for dates instead of writing dates in every other format that exists in the world. And there are many of them, by the way. Clean your data, of course, very important. Remove your typos, remove your outliers, remove your duplicates. They are very important. Add context headers. When you say monthly revenue USD, if the company is global, like Jen's company is, my company is, we are global. We need to say what the currency is. Otherwise, it might be treated as a local currency. It might be treated as euro. If someone is in Europe, it might be treated as Singapore dollars. If someone is in Singapore, so matters. What column are you talking about? Use templates. Extremely important. The common data, use a simple template and try using that. Golden rule, if a human can't quickly understand your data, neither can AI. And I keep saying this. Is it human readable? If it is human readable, yes, AI can help you make it better. If it is not human readable, AI is going to take much more power and it will be a chaotic situation then. So, what are our guardrails? Toxic content. Please remove all biases. That's how we started it. Please remove all biases. Have a clear content guideline. Then what are our prompts? Our prompts are, give it a context. If you're doing doing Agentforce in your organization or the trailheads, you'll see it'll ask you for prompting. There's a whole prompt builder. It'll help you understand how the prompts go. It's superb. It's easy. It helps you even when you're going into Gemini or Cloud or anywhere, ChatGPT, and you're trying to ask AI questions. If you do that prompt builder, you will be so much better at getting the right answers from there. So highly recommend doing the prompt builder. Overconsumption. Yes, you cannot overconsume the data. Every API call, and Jen wants to present on APIs soon, every API call costs. If someone says we want to hit your API every second, please tell them not to do that. It costs. It costs a lot. And there's no limit.
Yeah, I can't wait to do that presentation.
Yes, next one would be on Jen's API calls.
There's new API logs available too that just came out in June. I don't know if everybody on the call knows, so we'll cover that in our next meeting.
Okay, hallucinations. Yes, we love hallucinating. Humans like hallucinating. So does AI. We all hallucinate. So be aware of it. Choosing your model. I explained there are compatible models you created. Choose the best one depending on your use case, your requirements, and the performance you need. If you need something that 50% accuracy is good, go with it. Sure, you don't need 100% accuracy there. If you need 90% accuracy and some model is giving you 90% accuracy, go with that. Choose what you need. Choosing your model size. Again, do you need a smaller model? Do you need neural network? Will a decision tree work for you? Choose what you need. Doesn't have to be the same for every use case. Okay, Salesforce, and we have 6 minutes. Okay, Salesforce, let's see. This is your Agentforce part. This whole thing is Agentforce. Here you have your Salesforce platform, which is Einstein AI and models. Einstein Vision falls under Einstein AI. You have custom apps, agents, flows, which is again automation, which is also AI. Security and privacy. Of course, it's all built in security and privacy. Analytics, CRM analytics, Tableau, Salesforce analytics, which is the reports and dashboard section. They are all here. And you have MuleSoft integration, which is the APIs. Data Cloud is zero copy. Of course, we know that, at least by now. You have your industries, you have Slack, you have sales, marketing, experience cloud, you have Tableau and Tableau Next and everything coming here, revenues, and you have your partner and custom apps. Okay, how does all this come together and how does data connect together? So it connects, as we were saying, all your data sources together. By the way, Agentforce and Tableau Next are built on top of Data Cloud, and that's why we are talking about Data Cloud here, no other reason. So you connect everything, you harmonize the data, so your transformation, your models, everything comes here. You resolve customer identities, you tag and classify. This is actually coming very soon for Agentforce as well. In Data Cloud, tagging is coming very soon. You have defined policies and then you enforce them. That is where your security and privacy goes. Then you go into insights, you have predictive models, you have segments, you have actions, you have search and RAG, and then finally, you activate everything for with Agentforce analytics, Salesforce apps, ad platforms, and third party business apps. There's your data governance. Currently, this is the tags, and this is the part I said is coming very soon. It isn't yet there. So, AI and tagging is currently in beta. So, it's coming soon for everyone else to use if you have Data Cloud. But that's coming soon, and you can now tag your data, which is awesome. Then since we are talking about it, see, we have structured data, which is our data sets. And you have the unstructured data, which are emails and Slack and everything. Then you have your zero copy, which is AWS, Azure, and MuleSoft, and all of. You have your third-party integrations. They exchange the data via a private connection. It's not public; it's a private connection. It goes to Data Cloud. You build your you have your policy-based governance. Then you have the AI tagging. You have your data space management, and you have your platform encryption and Data Cloud. Ultimately, this is what we are all talking about. How do you share your data? How do you do Agentforce? How do you do your analytics, your segmentation? All of them. So now that we have spoken about AI and how Salesforce is doing it, let's all wrapped up in 3 minutes. AI powered analytics ecosystem. Tableau Next plus Agentforce. It's transforming your prepped data into intelligent action, right? So your AI ready data foundation. So toxicity filtered. That's your bias. Your context enriched. We already spoke about it. You have optimized consumption. We need it. We cannot hit our APIs every second. Hallucination prediction. We don't need humans hallucinate. We don't need AI also to hallucinate and give us something that we won't understand later. And we need a right sized model. Everything is from clean, structured, AI optimized data flows. Very important. Needs to be clean, needs to be structured, it needs to be AI optimized. Okay, so this is where the magic finally happens. Your Tableau Next is AI enhanced visual analytics. Yes, we are all visual people, we are all data people. That's where it is. So, natural language queries, automated insight generation, AI suggested visualizations, predictive analytics, smart data preparation, and anomaly detection. And then you go to Agentforce, it goes to automated decision making, intelligent workflow execution. And when you look at Agentforce, you will see more
We lost you for a bit, I believe. You're on mute. You're on mute.
for how long did you lose me?
I like 30 seconds. Last 30
30
seconds.
seconds. Okay, so this page, right?
Yes.
Okay, so I'm going to start with Tableau Next. So Tableau Next AI enhanced visual analytics. So we are doing natural language queries, automated insight generation, AI suggested visualizations, predictive analytics, smart data preparation, and anomaly detection. So once you do the Tableau Next semantic layer and Tableau Next Trailhead, you will see how this all comes together. Same thing with Agentforce, all the intelligent workflows and proactive problem solving, you will see all of those as well when you do the trailheads or if you're using it for your own company. So these are all coming together in the form of unified intelligence outcomes. So insight driven actions, proactive response, predictive optimizations, continuous learning, dynamic dashboards, and business acceleration. So the magic happens when Tableau spots a trend, or Tableau Next spots a trend. Agent Force takes action. You get the feedback to Tableau Next, and your cycle repeats and improves itself. And there it is. Any questions? And I know we lost a lot of people because this ran over time.
It was very detailed, actually. Like,
Yes, that's why we
so
said,
much.
yeah,
Yeah.
we can divide it into 3 or 4 sessions as well if you guys wanted. But this was just
Sometimes
the
it's good
gist.
to just get it all on the table.
Yes, we wanted to get it all on the table. Yes, thanks for saying that.
And then we can talk about each part of it,
Correct. In a
and
separate
have
meetup.
people ask us questions.
Correct.
But that was the presentation they sent us that we kind of modified. Well, Scientani modified it, but that's if you go out into our ecosystem, that's what's going to be thrown at you, right? And we're trying to take this down to digestible pieces. In a way, sometimes I think they don't want people to absorb everything, because I thought this would be given to us in smaller chunks in the
Correct.
industry over the next couple years, but instead they just kind of piled it.
Piled
It's,
it on us.
okay,
Yes.
everybody, do AI here, do agents here.
So the other thing, are there any Tableau Next hands-on modules? Yes, you do have them. There's I think one, not too much. There's one project I think in the, at least when I did, there was only one project in Tableau Next. So you might want to go and see that. And yes, thanks, Shubhadeep. We have to train AI to take holidays apparently.
Yeah, if you train it hard enough, it will learn what holidays are and it will start taking it.
See, I know Uzma has dropped off, but for your question, there is actually we did I think in January or February we did CRM Analytics plus Agent Force meetup, which
Yes,
you can
yes.
find on uh, the YouTube Einstein Analytics, well, CRM Analytics. I hope hopefully the name change channel, but that is a channel we have where whatever meetups we do, not just US, but also UK, we post it in there. So once I post this recording there, you'll have the link to the channel, and then you can find the Agent Force plus CRM Analytics in there. That was given by Santiago. He's a he is a Salesforce person who created it. So yes, you can definitely do that.
Now that we've
Yeah,
completely
it was
overwhelmed
called like
everyone.
CRMS teen or something. CRMS time. It was nice.
It was magic. Yes.
Yeah.
So any other questions before we stop recording? Or I can stop recording and then you guys can ask questions. Let's do that.
It's a lot.